Bevy 0.11 has Gizmos. Welcome to Bevy 0.11, which always contains an impressive amount of changes for every 3 months. But first, back to the super technical term, Gizmos. Gizmos refer to the ability to draw random lines on screen, often for debugging purposes. If you've ever seen the lines XYZ in something like Blender or any game engine, that's what a gizmo is. Before Bevy 0.11, there was some third-party support for some gizmos, but having it in core is really amazing. So let's start off with a couple of quick hits. Bevy has a default font now, so I'm going to remove the custom font handling lessons from the Bevy game examples on Rust Adventure, which is honestly really nice because it wasn't a requirement for building a game or learning Rust. But let's say you've built a game already, and now it's time to share it. Bevy now has a screenshot API. The API is fairly simple, but works pretty well. And of course, there are shader updates, and we love shaders on this channel. Bevy's WGSL shader implementation now uses Naga Oil, or OIL, which as far as I can tell is Bevy's continued approach to modularizing WGSL. Naga Oil gets rid of the global scope, so you won't be confused about where an item comes from anymore because all imports have to be specified explicitly. I think this is a great trade-off, and using the Naga internal representation rather than concatenating text files brings a lot of additional benefits. For example, there are now new directives like else if, and code span reporting for when you write shaders and they produce errors is now a thing. And honestly, I cannot tell you how useful code span reporting for shaders is going to be. All of this leads to some really interesting future work because being able to inspect and modify shaders at runtime is really powerful. It's also now easier to do custom render graph work with some of the boilerplate being simplified and some additional helpers being added. If Bevy's huge v3 scheduling update in 0.10 was hard to wrap your head around, those APIs got a lot simpler. And it's safe to say that there have been great improvements to the experience of using these APIs. There are now schedules and the systems you're adding them to. Done. And you can arbitrarily nest systems and configurations. So you could have a chain of 5 systems with 3 of them in the middle nested and chained together to run in order, which allows building up graphs in a more intuitive way. Bevy UI got CSS grid support, which is really nice, as well as the ability to render and color borders. There's not a whole lot to say here. Grids are great and we knew they were coming, and Bevy UI is getting pushed forward every day alongside the underlying Taffy layout crate. Another really useful piece is the addition of Atlas image bundles as a UI node. This will have a greatly simplifying effect on the, say, grid layout and character selection for the Snake workshop on Rust Adventure. Before Bevy 0.11, there were a bunch of different light sources, but only some of them supported shadows. Any lights that have a real-world analog, like a spotlight or a point light, generate shadows previous to Bevy 0.11. Alongside that, large directional light like the sun or the light sources that mimic the sun also produced shadows. Now, with screen space ambient occlusion or SSAO, the softer, more indirect lighting like ambient light or environment light can also produce shadows, resulting in a more realistic, more immersive environment. Screen space ambient occlusion is powered by compute shaders, so won't see WebGL support, but WebGPU support is on the roadmap, and WebGPU support is the future. Using screen space ambient occlusion with the next feature, Temporal Anti-aliasing, leads to a very large increase in quality, as well as noise reduction. Besides MXA and FXA, Bevy now supports TA, or Temporal Anti-aliasing. Temporal Anti-aliasing smooths out the currently rendered frame by blending it with the past frames. This results in a softer, smoother look and smooths over a lot of the artifacts that you might generate otherwise. It is marked as experimental due to the fact that temporal anti-aliasing doesn't work well with some other Bevy features, as well as having a hidden set of heuristics that are not user configurable and are subject to change. We briefly spoke about how temporal anti-aliasing creates a softer, blurrier image, but sometimes that's not desired. And this is where Bevy's support for AMD's robust contrast adaptive sharpening comes in. The acronym for that one is RCAS. The effect is subtle, but reminds me of what I used to see in PS2 games or earlier video games, compared to the sharper, higher-end graphics look of modern video games. The effect is subtle, especially when we pan through this example, but I think it will be very obvious in larger games. When it comes to animation, there's skeletal animation and morph targets as 2 of the options that you have. Skeletal animation being constructing a set of bones that you attach to a mesh and then you animate those bones back and forth. Morph targets, on the other hand, is like taking 3 different placements of the vertices for, say, somebody's face and morphing between them by using a percentage from each of them. So if you've got face A position and face B position, then you can animate between them by using a weight for how much of the vertice position should be taken from the first one compared to the second. This can be useful for lightening the workload of, say, hands, or making more expressive faces. I find that the Bevy example reminds me of The Sims, so I'll just put that out there. My first experience with parallax mapping was this example from the Bevy mod ParaMap crate. It's extremely impressive, and now Bevy has parallax mapping built in. Parallax mapping is one option for fixing the error of having brick walls that are just a little bit too shiny. This is achievable because the parallax map actually makes one pixel hide another pixel. So the little concrete between the bricks can be inset, and the brick can actually hide pieces of it that you aren't actually supposed to see. This is better noticeable in this example of a rotating Earth. The top half uses parallax mapping and normal mapping, and the bottom half uses only normal mapping. You can see the mountain ranges as they rotate through actually hide the land behind them in the parallax mapped use case. And if you've been looking forward to building larger environments, skyboxes are now a thing. A skybox is basically a giant cube that you take a cube-shaped texture and paint the inside of. So this cube will then contain your entire environment, and you'll be looking at the inside walls of this giant cube. In sort of simpler terms, it's like you're painting the sky. HDRI textures are already supported, and procedural generation of these cube maps is on the roadmap. You can now fix that N64 Rumble Pack itch with Bevy's support for force motors. You can of course control which motor to activate, how long, and how intense those vibrations will be. So in my head, that obviously says, time to build a kart racer. There are also a bunch of performance improvements and quality of life additions like the has query. Has will now return a Boolean if the component that you're looking for exists on the entity that you're querying. And finally, as we've covered on the channel before, Bevy 0.11 fully supports WebGPU. WebGPU is a modern standard for graphics and compute on the GPU, and it's already available in Chrome as the successor to WebGL. If you want to find out what WebGPU support means for the future of Bevy, check out this video, and I'll see you in the next one. Have a great rest of your day.